Now we go to classification. So classification, as we said earlier, classification is also about predicting supervised learning. Okay, so keep this in mind. So this is supervised anyway. But the difference between regression and classification, what you are trying to do? To predict qualitative output, where you have classes, you have groups, you have categories. You no more, you are looking for actual value. You're not looking for continuous value. You're looking just for categories. Like I provide his characteristic. He tells me, should classify him, whether he likes, what football team here you have famous in Malaysia. What are the names of football teams? I'm not, anyway, I'm a football fan. So even if you ask me about my country, maybe just, I can't recall one. But what do you have famous football soccer team here? Or you don't like also soccer? You like? You like? Nobody likes. Wow, that's great. If you go to my country, I think majority of the people are fan of football. Anyway, so meaning when we have classification, when I provide the characteristic, let's say, for example, I'm trying to predict whether the student is comprehend the course or not. So let's say I put camera here, capture your characteristic, and then the neural network is going to tell me, oh, these students, they have question, they don't understand. Would be nice, right? Especially if I put here goggles, and then I see you, what's happened in your brain. Or maybe you can show me there's food here, someone is thinking about breakfast, like probably me. Others may be thinking about going for a picnic next week. You have holiday for 2 days, right? So classification meaning just I'm trying to predict which group you are. Maybe let's say you understand, you don't understand. You like this food, you don't like this food. You are year 2 or year 1 student. So there are categories, right? But in regression, we are trying to predict the actual value. Like I'm asking about the income, or maybe I'm asking about your age. These are real values, are not categories, right? So one example of algorithm that works with classification is called logistic regression. Keep this in mind. So regression is not about regression, the one we talked about. But this one, logistic regression, is only usable for classification. You cannot apply logistic regression for to predict actual value. Okay, now we see why. So logistic regression is used to categorize, you see, to categorize data into discrete classes. This is why they call it classification, or categories, if you like. Okay. So you're not upset. Anyone doesn't like classes, the word classes? Don't be upset. You can use categories, you can use groups, you can use something relevant, fine. So find linear, you see, we don't call it, earlier we call it, we're trying to find the best line or fitted line that represent the data. Here we're not looking for a line that represents the data. We're looking for a line that disgregate between data, okay? What we call it boundary. So we're trying to find a boundary, okay? Or disgregate between data. Earlier, we're trying to find a line that represent. Here, no more. We're not looking for a line to represent, but we're looking for a line or a way to disaggregate, okay? Like here, I have, let's say, 2 groups, group 1, group 2. Then I'm trying to find a way to disgregate between you or segregate between you. Then what do? Maybe I find this line. I draw a line here. I say, this is your boundary. So group 1 here, group 2 here. Anyone step this boundary, go to the other side, then he is from group 2. Anyone go on the right-hand side of this boundary, then he's group 1. You see different. While in regression, I need to find a fitted line that represent all of you. So maybe the line is going to cross this section, all of you. Okay? So different. Keep this in mind. Why we're saying this? Let's take this example. So let's say I have my dependent variable, which is categorical or discrete value, can take value 0 and 1. So let's say assume 0. Let's say we're trying to predict the gender. So let's say 0 is male, Y is female. Okay? Now if I draw my data is going to look like this. You see the green dots? These are my data points, the individuals like you, let's say inside this class. Independent variable, whatever. I don't know, I don't have something in mind, but let's say whatever the input feature, whatever. So now we are interested. Why we're talking about classification? Because we have target variable, which is categorical or qualitative. Now, if we go with regression, linear regression, like the earlier slide we were discussing, is it suitable? Does this segregate between, this is group 1, by the way. This is for female data points, and this is male. Is this proper way? No, because as I said, classification is about segregation, right? Putting boundary. So is this boundary correct? Can I say this boundary, any person on the right-hand side is male, any person on the left-hand side is female? Cannot be applied, because here they're going to be, if this is on the right-hand side male, assuming this is female, then those for female, all of these are error. Wrong classes. We call it misclassification cases. How about here? All of these are misclassification cases, right? So these, if I need to draw in red, I don't know how. Oh, okay. So these are going to be error. These are error. Because regression is not about segregating. It's about finding a line that represents all data points. And here I don't care. I'm not looking for a line to represent you, but I'm looking for a line that segregates between the two data points, between the two sets of group, right? If this is regression, or this, if I found this line, then fine. Maybe I would say any data points that is above, let's say 0.5, those cases are for female, while any cases below, then it is male. So anyway, the point is regression is wrong choice, because regression doesn't have the ability to find boundaries. It's not about drawing or finding boundaries, but it's about finding representative line. Okay, so what we do in this case, we may go to logistic regression, because logistic regression can do exactly what we want, can help us to segregate between two sets of data points. So let's say logistic regression, by the way, looks like this, like S-curve. Now, how this is useful, when you apply logistic, it's going to also give you equation, by the way. It's going to also give you equation. Then what do you do? Every time you substitute a value, is going to give you a value between 0 and 1. This is first. Logistic is give you output between 0 and 1. And this 0 and 1 value in between, we consider it as probability. Probability. We're not talking about actual Y. We're talking about the probability. Because if I tell you, if I calculate here Y hat, and I got value here 0.7, can I say this person is female or what? Or male? Cannot tell, because this is probability, 0.7. So 0.7, if I got the case, this one, meaning the person is female by 70%, right? The person is female by 70%. That means what is the chance of the person being male? Is only 30%. So if we are looking for a greater value, then we can conclude this is female case. So again, logistic regression is just a curve that helps you to find value for Y between 0 and 1, and this value just represents probability. Okay, probability. So let's say we put threshold 0.5 here, which is by default value, let's say 0.5. So any value, any probability that is greater than 0.5, we can consider this as female. Any probability that is lower than 0.5, we can consider the person as male. Clear? So this is probability. This is not actual value, or some people call it logit. Logit value. Okay? Clear? Clear. 100%? 100%. Now I can't say anything because nobody says otherwise. Silence means agreement. You have a question? No. So as I said, this is called logit regression. The purpose of logit is to estimate the probability. You see difference, an instance belonging to specific class, specific groups. Example, application predicting probability that email is a spam. So you're building a filter that helps you to distinguish, to segregate between males and female, between ham and spam emails. So the threshold of classification, typical cases, 50%. If estimated probability exceeded the threshold, the model classifies as it is positive class, labeled 1. So what does 1 represent in your case? Maybe let's say 1 means spam. Then if you got value, probability greater than 0.5, then that means this is spam email. 0.5 and above means spam email. Okay? Binary classification, so threshold, because we have different types of classification. We're going to discuss about in the next model when we start next model. So binary classification, simply you are looking only, you have two categories, two classes, like male, female, exist, doesn't exist, spam or ham, apples or orange, okay, and so on and so forth. So you have only two. So an instance that is labeled as 1 belongs to positive class, an instance belong as 0 becomes negative class. Okay? Any question? No question. Decision rule. Decision rule or the boundary. Again, the decision rule, or you are looking for the rule that actually explains. This is like the pattern. You are looking for the pattern. So earlier in regression, we were looking for the mapping function that map between the input and the continuous feature of output. The output target variable is continuous, right? So earlier we were looking how we explain we're looking for a pattern that explains the relationship between both. Same here. So decision rule, we call it for classification case where you are looking for the pattern. So if the estimated probability greater than the threshold, then you are predicting positive class. If estimated probability is less than threshold, then you are predicting negative class. I don't know here if we have an example, we don't have. Okay, so back, yes. Yeah, decision rule just simply means the pattern. The pattern. Like insight, what insight you found inside your data set, the pattern. So you may say, okay, if we are trying to predict, let's say, high income and low income. So maybe high means 1. So this is high income, and this is low income. Okay, high income and low income. So let's say, assuming you found whatever you were able to map the value, and your threshold, assuming is 0.5, because not all the time the threshold is same. So assuming 0.5, so you may say if the estimated probability for based on X, whatever X you have, is greater than 0.5, then this person is high income person. If it's lower than 0.5, then it is low income person. Okay. Later also we look into decision tree. Decision tree is more interesting than just having this rule. Okay, because 0.5 is just probability. But decision rule, decision tree, later we're gonna find, is actually can explain more detail. Can tell you, let's say assuming this is age, so it can tells you if a person age is greater than 35 or let's say 40, then this is rich person. If it's lower than 40, then this is low income person. So can give you plain words. Probably logistic regression can do so. Can do so. Maybe we try to check. You see how time flies with just the slide. We finished 10 slides. I think I should go faster, right? Because all of you have no questions. So you're the expert. I should go lower. This is just comparison between the 3 regression. Again, linear, polynomial, for continuous output, where you have target variable as continuous or quantitative. Right? Logistic is for classification. So this is for regression. In other words, these for regression, the one we were discussing earlier, this is logistic for classification. Okay, so this is the summary between all.